In the last lesson, we did confidence intervals comparing two population means. Now we're doing a hypothesis test comparing two population means. Okay, so when you compare two means, the way you compare them is you find the difference between the two of them. So our null hypothesis is going to be that one of the mu's minus the other mu is equal to some hypothesized value. Usually that'll be 0. Okay, we have 3 options for the alternative. One could be that it's greater than some number. One could be that the difference is less than some number. Or you could be testing that it is just not equal to some number. The p-values associated with each of these is, so for the first one, it's the area right of t. For the second one, it's the area left of t. And you have a few options for the third one. It could be the area left of negative t, or it could be, well, I should say 2 times this area, or it could be 2 times the area right of t, or it could even be the area left of negative t plus the area right of t. Okay, there's a formula for the t test statistic. The actual difference in the x-bars minus the hypothesized difference in the x-bars over the standard deviation of the difference. When you find the standard deviation of the difference, you add the variances together and take the square root. The degrees of freedom formula is shown. You'll probably never need to use this formula. I think in the last lesson I told you guys to round that number up. Well, I was actually wrong. You need to always round this number down. So truncate means round it down. Okay, in example 1, there's a question, are women still paid less for comparable work? Study was carried out. They took a random sample of men, a random sample of women who worked as purchasing managers. They tell us to use alpha equals 0.05. Is there convincing evidence that the mean annual salary for male purchasing managers is greater than the mean annual salary for female purchasing managers? So we'll start with the hypotheses. So HO is going to be that. So the way they word it, they say, or they ask us to find if there's evidence that male purchasing managers earn more. So I'm going to write mu for male. And it's always a good idea to use subscripts that indicate which mu it is. That way you don't have to make another line and say what mu1 is and what mu2 is. So mu for the males minus mu for the females equals 0. And then our alternative is that mu for the males minus mu for the females is greater than 0. So they ask is there evidence that the salary for males is greater than the salary for females? So if it's greater, that means when you do male minus female, it should be positive or greater than 0. Okay, after we do the hypotheses, we check conditions. So first condition, random or representative. They tell us that a random sample of women and a random sample of men we're taking. Okay. Okay, condition 2. This is satisfied either by the CLT or by checking the graphs to see if they're approximately normal. So CLT won't work because we don't have at least 30 for each group. So we're going to have to check the normal probability plots. And they look good for both distributions. So I'm going to write the normal probability plots for both distributions display a roughly straight diagonal line indicating both populations are approximately normal. Okay, the third condition is the independence condition. So we're going to have to assume we will assume the two groups are independent. Since the conditions are met, we can use a student's t-model with, okay, and now you're going to have to check your calculator for the degrees of freedom. So you'll need to enter in the data first and run the test. So enter in the data now if you haven't already. this is probably a good time to pause the video and enter in the data. So make sure you do this in 2 separate lists. Let's put the males in L1 and the females in L2. Okay, so once you have the data in L1 and L2, you're going to go to Stat, Tests, and you're going to go to 2-sample t-test. It should be number 4. All right, we had the data, so we're going to choose Data. List 1 should be L1, list 2 should be L2. We did not use frequency lists, so both of those should be 1. We want the greater than option. And for pooled, we're going to say no, and I'll explain why in a minute. And then calculate. Okay, so on the 4th line, you'll see that the degrees of freedom is 15.1. You were told to truncate that, so the degrees of freedom is 15. So we're going to use a student's T model with 15 degrees of freedom to conduct a 2-sample t-test. So after you run the test, you should report the test statistic and the p-value. So let's show our work for t. We have, so the calculator will give you these values. 74.6 was X bar for men. 64.6 was X bar for women. And we're just trying to see if men make more than women, so our hypothesized value was 0. That was the hypothesized difference, and the claim was that it's greater than 0. Okay, so our standard deviation, if you scroll down, you'll be given the 2 standard deviations. So for men, it was 5.3, 5.4. So it's S over 10. So that should be a radical 10 if I wanted the standard deviation, but I actually want to add the variances together. So I need to square the numerator. And if I square the denominator, the radical just goes away. Okay, so for this one, I want to square the numerator. And I want to square radical 10, so that just becomes 10. Then I add these together and I take the square root. That gives me the standard deviation of the difference. Okay, I'm not going to require you to show that work, but if you want partial credit, it's a good idea. I think it's probably safer to just write the answer because it's easier to mess up on the work. So I believe on the AP test, if you just write the t-value without showing the work, as long as you're correct, you should get full credit. Okay, the next thing I need to write is the p-value. So the p-value is 0.00356. Okay, and then we give our conclusion. Since our p-value is significantly less than alpha, which was 0.05. We reject the null hypothesis, or HO. There is sufficient evidence that the mean annual salary for male purchasing managers is greater than the mean salary for female purchasing managers. So earlier I told you for pooled to always say no. And the reason is that if you are willing to assume that the standard deviations for both populations are equal, you can pool the data, which makes the degrees of freedom simpler. But the advantage of this is very negligible. So it's never wrong just to say no to pool. So for pooled data, just always say no.